Okay, so this is the Intermediate Algebra Chapter 8 Review Part 1. There'll be two parts. This will be Part 1. So the first thing we're going to talk about is evaluating functions for specific values of x. So for instance, if say I have the function f of x equals 3x minus 1, and I want to evaluate it for two different values at x equals 3 and x equals 2/3. So if I want to evaluate at 3, well, f of 3, all right, because x is 3, so 3 goes here. So f of 3, well, that means for every x, I plug in 3. So 3 times 3 minus 1. Well, 3 times 3 is 9, minus 1 equals 8. So f of 3 equals 8. And now, if I want to do it for f of 2/3, well, I plug in 2/3 for every x, so 3 times 2/3, or 2/3, minus 1. Well, 3 times 2/3 is 2, because these divide out. Take away 1 is 1. So f of 2/3 equals 1. Now suppose I have another function, f of x equals 5 for the values x equals -5 and 7/5. F of -5, well, -5 goes here, and for every x, I plug in a -5. But wait, there's no x here. So there's nothing to plug in, it just stays 5. So that means no matter what x value I plug in, it's going to be 5. So it's a constant function. It's always 5. So if you want to do 7/5, it's 5. I could put 1,000,000, it doesn't matter. It's always going to stay 5. Okay, so the next type of problem is we're going to look at a set, call it S, and within this set we have the numbers -3, 4, that's a point. We have -1, 4. Yeah, another point is 2, 3. And the last point in this set is 4, -1. So I want to find the domain of this. Well, the domain of S is what? Well, domain is always all the possible x values. So I look at the x coordinates for every point. I have this one, this one, this one, and this one. So the domain is going to be -3, -1, 2, 4. Now I want to find the range. The range of S. Well, the range is all the possible y values of a function or a set. So what are my y values here? I have 4, 4, I have this one, 3, and then this other one, which is -1. Excuse me, which is -1. So what is the range? Well, it would be -1, 3, 4. Now, yes, I have 4 twice, but you don't have to list it twice because all it is just repeating. So there's no need to put 4 again. Now, if they ask you, well, given this set of points, is this a function? Well, by definition, a function is for every one input, there's going to be one output. Or for every one x value, there's going to be one y value. Well, when I input -3 for x, y is 4, x is -1, y is 4, x is 2, y is 3, x is 4, y is -1. So for every one x value, there's one y value. Even though these are both 4 here, it's still one x value because -3 gives me 4, -1 gives me 4, two different x values. And again, 2 gives me 3, 4 gives me -1. So this is a function. Okay. Now I'm going to clear the board. The next thing we're going to do is finding the domain of functions. So suppose I have f of x equals 2x plus 7. What is the domain of this function? Well, again, if I think about it like this, for every one input, there can only be one output, or for every one x input, there can only be one y output. For every one x, there's only one y. So if I plug in any real number for x, will it give me a real number for y? Well, let's think about it. Let's look at some examples. If I plug in 0 for x here, it gives me 7. And if I plug in 3, that gives me 2 times 3 is 6 plus 7 is 13. If I plug in -5, well, 2 times -5 is -10 plus 7 is -3. So for every x, there can only be one y. So that means the domain can be anything. So I'm going to write it like this, domain colon, an interval notation, right? The way you would write all real numbers interval notation is parentheses, -infinity, comma, infinity, parentheses. Now, anytime when you're writing interval notation, you have parentheses, that means you do not include it. The reason why -infinity and infinity are not included is because they don't have a finite value. You can't put a number on infinity. It's not like, oh, it's 1,000,000. No, it just, it doesn't have a defined finite value. Well, now suppose I have another function, g of x equals the square root of x. Now this one's a little bit different because I can't just put any x value and it would give me a y value. In other words, it has to be a real number to a real number. So we think about square roots. Well, if you take the square root of a negative number, it's not a real number, it's an imaginary number. So we can't include negative numbers. What about square root of 0? Well, it's 0 because 0 times 0 gives you 0. So then, if it's square root of 1, it'd be 1, square root of 4 would be 2, so on. So that means if I look at it and I want to know what it is exactly, well, it'd be greater than or equal to 0 because you can take the square root of 0 or any number bigger than 0. So hence greater than or equal to 0. So to solve this, I square both sides. These cancel. I have x is greater than or equal to 0. So in interval notation for the domain, since I have greater than or equal to here, I have a bracket because it's included, because 0 is included because of the equals. So it's bracket 0, comma, infinity. Infinity is not included because, again, you can't define it. It's not a finite value. You can't put a number on it. Now, keep in mind, anytime you have a radical function involving a square root like this, you could always set it greater than or equal to 0 and find the values. So if it's like the square root of x plus 7, I can set that to be greater than or equal to 0 and then solve it. Now, suppose I have another function, h of x equals x over x minus 3. Well, it's a rational function, which is a polynomial divided by a polynomial, or a polynomial over a polynomial. Well, another way to look at this is x divided by x minus 3. Well, there's only one number you can never divide by, and it's mathematically impossible to do it, and that's 0. Any number divided by 0 is undefined. So, okay, I have to look at, well, how does this become 0? Well, the way to know that for sure, you take the denominator here, which is x minus 3, set it equal to 0, solve for x. X equals 3. Now, that means the domain is all real numbers except x cannot equal 3. Well, how do I write the interval notation? Well, to have some help with that, the way I look at it is this. You have a number line here, right? If I draw a number line and look at it this way, I have my number line, x equals 3. Domain is left to right. So from here to here, it's -infinity to 3. So my domain, -infinity, which is not included, comma 3. Since 3 is not defined in the function, it's not included. So that means I have to put a parentheses. Now, I go from here to here. Well, that's just 3 to infinity. So I have to put a union. Again, 3 is not included. and neither is infinity. So the domain of this function is negative infinity to 3, union 3 to infinity. And that's going to do it for part 1 for this video. I hope this helps, and I'll see you at part 2. Have a good day. Bye-bye.